Math 1314, section C87. It is not C87, it's actually C83. Homework 7, distance, midpoint, and circles. Video 2, the distance between 2 points. As the name of the homework implies, there's 3 different skill sets that are being assessed in this homework, all of which for the most part are fairly short, or rather at least 2 of them are. That would be distance and midpoint. The circles one will invoke a longer discussion. But for this video, we're going to talk about how to calculate the distance between 2 points, which is exactly what it sounds like. Here's 2 points on a coordinate plane. How far apart are they? Now, granted, sometimes you could just break out a ruler or a measuring device, figure out the distance between things, but sometimes that's not practical because there may be obstacles between the first point and the second point, or they may be so far apart that getting a measuring device isn't actually practical. So how do we find the distance between 2 points? Well, let's consider this example. Consider the points 2, -1 and 8, 7. What is the distance between these 2 points? You'll notice I've already got both points plotted. Here is the 2, -1 right there, and here's the 8, 7. So let's go ahead and label those. 8, 7, and 2, -1. And the question is, how far apart are these? Well, anytime you don't know a value in an algebra context, the best thing to do is to represent it with an unknown value, in other words, a variable. And I think a good variable to represent distance would be d. So we're going to call the distance between these 2 points, the length of that line segment, if you will, d. Now, how can we figure this out? Well, there's an easy way to figure out, if you remember a little bit of basic geometry, something called the Pythagorean theorem. Pythagorean theorem is spelled P-Y-T-H-A-G-O-R-E-N-T-H-E-O-R-E-M. A theorem is just a statement in math that has been proven to be true. And a lot of people know the Pythagorean theorem. They may not know it by name, but they usually know it by sound. The Pythagorean theorem is what most people call a squared plus b squared equals c squared. Be right back. What was just a moment of time to you was actually a pretty long break for me, meaning that I don't remember exactly the last thing I said. So we're going to resume this problem from the beginning. All right, consider the points 2, -1 and 8, -7, which are already labeled on the picture. What is the distance between these 2 points? And we're labeling the distance between them as d. In other words, we want to know how far apart or how far that is. And oh yeah, we were about to remind ourselves what the Pythagorean theorem was, that a lot of people remember the words Pythagorean theorem and may not remember what it says, but they probably remember hearing a squared plus b squared equals c squared. It's funny that a lot of people can rattle that off. A squared plus b squared equals c squared. But when you ask them, what does it mean? They're like, I don't know. Just a squared plus b squared equals c squared. What it is, it's a statement about the 3 sides of a right triangle. A right triangle being a triangle with a 90-degree angle. I usually draw mine in the lower right corner, but it doesn't have to be. Where if the 2 sides that make the right angle, A and B, those are called legs. But if those 2 sides are called A and B, and then the longest side called the hypotenuse is C, then whatever A and B and C equal, they satisfy the equation a squared plus b squared equals c squared. Now, how can that possibly help us in this picture? Because we don't have a right triangle. We don't have a triangle at all. All we have is this line segment connecting the 2 points that we're trying to find the distance between. Well, a common problem-solving strategy in math is to add things to a picture to help you see something that can help you. And in this case, we can draw this triangle by moving over and up to that point. Not perfectly drawn to scale, but good enough for our purposes. And here's there's the right angle. So if we knew how long those 2 blue sides were, then we could do the Pythagorean theorem and figure out the distance between the 2 points. And although we don't initially know how long they are, we kind of actually do. Because think about it. The blue side on the bottom, going from left to right, begins at 2 and ends at 8. And so that bottom side of the triangle represents the distance between 8 and 2. Well, we can just subtract those 8 minus 2, and that'll give us 6. So we know how long that bottom side is. And as far as the side on the right, we can do the exact same thing, and that's going from -1 to 7. And if we did the same subtraction problem, 7 minus -1, then we would get that the length of that side of the triangle is 8. You could also just look over here and go, well, that's 8 spaces. But it won't always be practical to look over on the y-axis or the x-axis and count spaces. However, we can always do a subtraction problem. And speaking of which, now that we've done this first subtraction problem to figure out that that was supposed to be a highlight, to figure out that the length of this side on the bottom is 6, and another subtraction problem to figure out the length of the side on the right is 8, we can do the Pythagorean theorem with the 3 things that I have highlighted, and we can calculate the distance between those 2 points. So let's set up the Pythagorean theorem. Instead of a, we have a 6, so 6 squared, plus, instead of a b, we have an 8, so 8 squared, equals, instead of a c, we have a d, so d squared. And this is just a quadratic equation. It's a real easy one to solve because everything on the left side are just constants. 6 squared is 36. 8 squared is 64. We'll worry about the square on the d in a moment. 36 plus 64 is 100. And now we have a quadratic equation with a single d term this time, so we can solve it using square roots. If we square root both sides, we would get d equals plus or minus the square root of 100. Remember, when you square root both sides of an equation, use a plus minus. And of course, the square root of 100 is 10. So we get a d equals plus or minus 10, at least algebraically speaking. Geometrically, in other words, on the picture, one of those answers doesn't make sense. We're measuring the distance between 2 points. Distance is never negative. So this is a case where algebraically the plus minus is supposed to be used there, but geometrically what we're solving for can't be negative. So we can just get rid of the plus minus and say that this distance is 10. Now, if you're thinking, am I going to have to jump through all these hoops every time I do a distance problem? Am I going to have to draw the picture, draw a triangle, subtract to figure out how far each side is, do the Pythagorean theorem, and then solve for d? Am I going to have to do that all the time? And the answer is not entirely. One thing we don't have to do is draw the picture. It helps, or at least it helped motivate how to figure out the distance between these 2 points. But if you're trying to find a more efficient way to do something, you should try to do it full blast from beginning to end specifically. So in this case, we specifically used these 2 ordered pairs. Then, in an effort to come up with a more efficient way to do it generically, make it generic, meaning replace the numbers with letters, but run it full blast from beginning to end and look at the end results. So we're going to attempt to derive a formula by, well, here I kind of said we're going to give you the formula, and I was originally going to just do that, but I'll show you where it comes from. We're going to derive the formula by doing the exact same thing that we just did, but now we're going to use 2 generic points, x1, y1, and x2, y2. Now, normally when you write these, the numbers are subscripted like this, x1, y1, and x2, y2, but I can't type subscripts in the word processor in Zoom. So the best I can do is type X1 and Y1. So anytime I type them, I'll type them same font size, same level. But when I write them, I'll always write the numbers as subscripts. All right, so how would we do this from a generic sense? Well, think about what we did back here. When we found the distance, but when we found the length of the bottom side, we subtracted the x coordinates. We subtracted 8 minus 2 to give us 6. And when we found the length of the side on the right, we subtracted the y coordinates, 7 minus -1. So if we were to set up the same picture, generically speaking, x1, y1 representing the coordinates of the first point, and then x2, y2 representing the coordinates of the second point. In other words, this first point is over x1, over x1 and up y1. So its coordinates would be x1, y1. And then for the second point, it would be over x2 and then up y2. So that would be the coordinates of the second point. But if we want to find the distance, let's replicate the same thing we did just a second ago. We made a right triangle by moving across and then up. And then we found, we don't have to draw the right angle, I just like to emphasize it. Then we found how long each side was by doing a subtraction problem. For the bottom side, we subtracted the two x coordinates. So if we subtracted them here, it would be x2 minus x1. And then on the right side, we found its length by subtracting the y coordinates. So we could do y2 minus y1. And then we did the Pythagorean theorem. I'm going to start the Pythagorean theorem in reverse this time. I'll say d squared equals, and then the sum of the squares of the two sides of the triangle, the two legs, I should say. The bottom leg is x2 minus x1. And the leg on the right is y2 minus y1. Do we need to FOIL that out? I wouldn't. Looks good the way it is. If you FOIL out either of the parentheses, you're going to get a pretty big mess. But I do want a formula that says d equals, not d squared equals. So if I wanted to solve for d, I would square root both sides, which would cancel the square on the d and just leave us with the d by itself. Now on the right side, you might be tempted to cancel the red square root with these two squares, but you can't. And the main reason you can't is because of the plus sign in the middle. You cannot distribute a square root across plus or minus. Let me say that again. You cannot distribute a square root across a plus or minus. In other words, if you have the square root of two things added together, you cannot distribute the square root across it. There are times when you can distribute a square root, but this isn't one of them. And the only way we could cancel the squares up here is if we could distribute the square root across the plus, which we can't. So what can we do with that mess on the right side? That big square root and everything under it? And the answer is not a thing. The square root of the sum of the squares of the differences. Before I write the x's, I want you to focus on the words I just said. The distance is the square root of the sum of the squares of the differences. Square root of the sum of the squares of the differences of the x coordinates and of the y coordinates. And this is your distance formula. D equals the square root of the square of x2 minus x1 plus the square of y2 minus y1. That is your distance formula. We are about to apply it. We're going to close this video with a couple of quick examples. Find the distance between the following pairs of points. A, the ordered pair -10, -15, and the ordered pair 14, -25. Let's go ahead and do this one before we look at B. When you use the distance formula, the first thing you need to do is clearly identify the x1, x2, y1, and y2. Now you can do this mentally, you can do this verbally, you can do it on paper. I'm going to write it. Your first x is x1, your first y is y1, your second x is x2, your second y is y2. And I'll be honest, who you call first and second is completely arbitrary. There's no reason that I couldn't have written that ordered pair first and this one second. In other words, traded them off, making the second one first and vice versa. Because the order of something and something is irrelevant, who we call x1, y1 and who we call x2, y2 doesn't matter. What does matter is if you call one of the points x is x1, you better call its y, y1. All right, so you identify your players and then you get out your formula. Let's go back to blue. Distance is equal to the square root of the sum of the squares of the differences of the x coordinates and y coordinates. So just saying those words, one second, just saying those words can really help you set up the distance formula. And now we just got to drop everything in its place. Our formula said in the first parentheses was x2 minus x1. We've already got the minus. Now we just need to drop the numbers in. x2 is 14. x1 is -10. Be careful. There was already a minus from the formula. The 10 is bringing in a second minus. And then for the y's, the second y is -25. And the first y is -15, as if we didn't have enough negatives already. Once you get the distance formula set up, then you just go inside out. You start with the parentheses, then square, then add, then square root. All right, so let's take it one step at a time. If we do the subtraction problems and leave everything else alone, what is the answer to the first subtraction problem? 14 minus negative 10. Well, the double negative makes it a plus, so it actually ends up being 14 plus 10, which is 24. And on the other one, you have to be a little bit more cautious because we got a lot of negatives floating around here. But again, minus a negative makes it a plus. I think I'm going to take this one out to the side. Negative 25 minus negative 15. The double negative makes it a plus plus. But now we're adding a positive and a negative. And when you add a positive and negative, you subtract. 25 and 15 subtracted give you 10. And then whoever was larger determines the sign of the result. Since 25 is larger and it's negative, I'm sorry, then the result is also negative. So now we have the square root of 24 squared plus negative 10 squared. And a real quick comment, the 24 doesn't have to be in parentheses, but the negative 10 does. If you write something like this, you are not squaring the negative 10, you're squaring the 10 first and then sticking a negative on the answer. To square a negative number, it must be in parentheses. Your calculator knows this too, so make sure you type it in correctly. All right, so if we square both numbers, and speaking of calculators, I would expect you to use one here. 24 squared is 576. Negative 10 squared is positive 100. When we add those, we get 676. And when you get to the square root, the first thing you should do is see if it works out cleanly by putting it in the calculator. If it comes out cleanly, I'm so sorry. If it comes out cleanly, meaning that when you square root it, it's a whole number, then hooray, we're there. The square root of 676 is exactly 26, and that's the distance between those 2 points. Now, sometimes the square root won't cooperate, as we'll see in this next example, but before we get there, I'm going to pause and get me a drink of water. All right, much better. All right, for the second one, it looks easier because the numbers 11, 3 and 2, 12, in case you're wondering where we're looking right here. Looks easier because those numbers are all positive. And what that means is that it's an easier setup. Whether or not it's an easier conclusion depends upon what happens under the square root. We're going to do this one in green just to contrast to the one we just did. Excuse me. At some level, identify first x, first y, second x, second y. And when I say at some level, that can be mentally, it can be verbally, or it can be written down, but you've got to know who your players are before you stick them into the game. All right, so our distance formula is the square root of the sum of the squares of the differences of the x's and y's. It's always second minus first, although technically it doesn't matter. We're going to run with it as if it always matters. All right, on the x side, the second x is 2, the first x is 11. And on the y side, the second y is 12 and the first y is 3. Let's see where that takes us. The answer to the first subtraction problem, 2 minus 11, is negative 9. That still gets squared. And remember, when you square a negative, it does have to be in parentheses. And speaking of parentheses, in the other parentheses, 12 minus 3 is 9, which doesn't need parentheses, but I'm going to write it just to be consistent. When I square each of those numbers, I get 81. And when I add those, I get 162. Now, if you put the square root of 162 in a calculator, it will not come out to be a nice round number. I'll show you. All right, 162, got to turn my calculator to get the square root out. And when I square root it, I get that number. There we go. Yeah, it's more than 12, but a 12-point garbage is what it is. And so in the homework, if you get a square root like this that doesn't come out cleanly, you're not expected to use a decimal. What you are expected to do, however, is to simplify this. So real quick on the next page, let's talk about how to simplify the square root of 162. And remember, I did show you a technique that will allow you to simplify any square root, but it does require you to break down a number completely. into a multiplication problem involving prime numbers. 162 is kind of a chunky number, but being even, it's pretty obvious it's divisible by 2. And if you divided 160 by 2, you would get 81. Now, if you're on top of your game, you'll realize that 81 is a prime. It's not prime. It's a perfect number to have under a square root. But let's pretend that you are playing the let me break it down completely game. 81 is 9 times 9. I meant to circle the 2 since it's prime. 9 is 3 times 3, both of which are prime. 9 is 3 times 3, both of which are prime. And again, some of you might be thinking, why are you breaking it down further? We found a perfect square. Because I want to remind you about the technique for completely figuring out how to break down a square root by putting your pairs in one square root, because pairs make squares, and your singles in another square root. So where are our pairs? Well, we have a 3 times 3, and we have another 3 times 3. The only one that's not paired up is the 2. That's a single. And now that we know how to split this, 3 times 3 times 3 times 3 ends up being 81. 2 is the only one in the single square root, and the square root of 81 is 9. Again, if you're really on top of your game and paying attention, the minute you broke off this 2 and saw the 81, you probably would have said, let me split it like that because I know the square root of 81. But I just went through the complete breakdown process to remind you how to simplify a square root when you're not sure of the correct move. But this would be considered your final exact answer. Exact as opposed to approximate. This 9 times the square root of 2 is exact because we didn't round anything. It is exactly that. It's a horrible thing to measure. How long is that? That's when you would get out a calculator and use a decimal. But in terms of precision, it's the most exact and simplified version of that answer.